Good day, everyone. So we are going to be looking at the second phase of limit, as I promised now, like in my last class, which is limit phase 2. So let's look at this. We have some examples on the board, so we should evaluate the following. We have, of course, limit of x squared minus 4 all over x minus 2 as x approaches 2, and also we have problem 2 and problem 3. So we're going to be looking at the 3 problems here. So let's start by looking at the very first problem, which is this here. Now, on the norms, from what I've explained in my previous video, I told you that if you want to evaluate limits, all you need to do is to substitute the approaching value of x. For instance, which is 2 here, you have to substitute it in this function, and then that gives you the limiting value. But if you try to do that here, of course, this one is going to give us 2 raised to the power of 2 minus 4 divided by 2 minus 2 here. Okay, of course, this will give us 2 squared is 4 minus 4 divided by 2 minus 2, which is 0. Then, of course, 4 minus 4 will give us 0 over 0. Okay, now you see that this particular 0 over 0 simply means undefined. Okay, and when you have such relationship in limit, all you need to do is to simplify the function before you substitute. Okay, that is the meaning of 0 over 0. In short, I do call it do something. It means you have to first of all do something to this function, okay, before you what? You substitute. That is in a condition whereby you have 0 over 0 after substituting directly. That is what I mean, okay? Now, let's look at what we can possibly do to this function. So we have limit of x to power 2 minus 4 divided by x minus 2 as x tends to 2. Okay? Now, if you observe this numerator, you discover that it's just like something like a squared minus b squared, which is the difference of 2 squared. And of course, this is equivalent to a minus b, open bracket, a plus b. Okay? So with this idea, you can evaluate this. Now, this is what you do. So this is going to be equals to limit of x to power 2 minus, of course, 4 is same thing as 2 raised to the power of 2. Okay? And then divided by x minus 2 here. As x approaches 2, as x approaches 2. And then expressing this in terms of difference of 2 square, you have limit of open bracket x minus 2, open bracket x plus 2. And then you divide everything by x minus 2 here. Of course, this x minus 2 eliminates x minus 2 from there. And then you'll be left with limit of x plus 2 as x approaches 2. Okay, then from here you can substitute directly now. Anywhere you see x, you put 2 there. So this becomes 2 plus 2, which is equals to 4. So 4 becomes the limiting value of this particular function as x tends to 2. We're going to do the same thing for problem 2, which is limit of x to power 2 minus 4x plus 4 all over x minus 2 as x tends to 2 as well. Now the first thing you do, is to substitute directly, okay? So substituting directly here, this gives us 2 raised to the power of 2 as usual, minus 4 multiplied by 2 plus 4 all over 2 minus 2. Evaluating this, 2 squared, of course, we are going to have it to be 4 minus 4 times 2 is 8, and then plus 4 divided by 0, which gives us, of course, 4 minus 8 is minus 4 plus 4, that's 0 over 0. And I told you that 0 over 0 simply means you do something, okay? So now, what do we do here? Let's look at this. You bring down your function, which is a limit of x raised to the power of 2 minus 4x plus 4 all over x minus 2 as x tends to 2. Okay? Now, this is different from this very one here. Okay, so you cannot apply the same idea of difference of 2 squared to this. But if you look at the numerator here, this is a quadratic expression, which you can actually factorize quadratically. And then let's do that. Of course, you know the rule. In factorizing, you look for two numbers in such a way that when you add them together, it gives you the middle value. And then when you multiply them together, it gives you 4. And mainly looking at this, the two values are -2 and -2. Of course, if you add them together, it's going to give you -4. And then if you multiply, it's going to give you +4. So you replace this middle term with those two factors. And then that gives us limit of open bracket x squared. We replace this with -2x minus 2x and then +4 all over x minus 2 as x approaches 2. Okay? And then evaluating further, this gives us limit. Of course, you factor out here. There is x here, there is x here. You bring it out, open brackets. X into x squared, you have x minus x into 2x, you have 2 left. And then negative comes in. And then here also there is a common factor here, which is 2, open bracket, 2 into 2x, you have x. Of course, plus divided by minus, minus. And of course, 4 divided by 2, you have 2. Then all over x minus 2 as x approaches 2. Wow. Now, if you look at the numerator immediately, you discover that there's what we call the shouting factors. Now, this will be equals to limit. These two are the same. So you pick one, which is x minus 2, open bracket. These two outside, you group them together, which is x minus 2. All over x minus 2 as x tends to 2. So this x minus 2 eliminates x minus 2. Of course, you'll be left with limit of x minus 2 all over, you'll be left with limit of x minus 2 as x approaches 2. You can now substitute directly now. From here, you can now have it to be 2 minus 2, which is equals to 0. So 0 becomes the limiting value of that particular function. This. So let's quickly look at the third problem. We have limit of 1 minus root x all over x as x tends to 0. Okay? Of course. Here, you try to substitute directly. Let's see. When you do that, this gives us 1 minus square root of 0 all over 0, which is equals to 1 minus square root of 0 is what? 0 divided by 0, which is equals to 1 over 0. Of course, 1 over 0 is quite different from 0 over 0. I probably drop this to explain something to you. When you arrive at 1 over 0, then your conclusion becomes undefined or does not exist or indeterminate. Okay? But when you have it as 0 over 0, it means you have to do something, either through simplification or other approaches, which we are still going to look at. Okay? Meanwhile, you can actually resolve all this using your L'Hopital's rule, which I'm going to do a video on that subsequently. Please do well to always subscribe, comment, and like my video or my YouTube channel for more videos. Thank you.